Okay, in example 2a on the left, we combine the chain rule with the rule differentiating the sine function. In general, if y is equal to the sine of u, where u is a differentiable function of x, then we can use the chain rule. So let's just go ahead and talk about how we would do it in this way. So that means that if we let y, or in this case here, we're going to let u equal x squared, and y is going to equal the sine of u. Okay, so that means that if we want to find the derivative with u with respect to x, then that's going to equal 2x. And we know that the derivative of y with respect to u is equal to the cosine of u. So if we would use that formula where it says that dy over dx is equal to dy over du times du over dx, then what we get is the cosine of u times du over dx, which is 2x. And so we know that u represents x squared. So this is the cosine of x squared times 2x, which would then give us the same result, 2x times the cosine of x squared. And so here we can say that in a similar fashion, all of the formulas for differentiating trigonometric functions can be combined with the chain rule. So let's make explicit the special case of the chain rule where the outer function is a power function. So if y is equal to the function g of x raised to the power of n, we can write y equals f of u, which is equal to u to the n, where u is equal to gx. And then by using the chain rule and then the power rule, we're going to get the following. So again, what are we going to say? We're going to let u equal g of x and we know that y is going to equal u to the n. So if we want to find the derivative with respect to x of g of x, so that's du with respect to x, well, that's equal to g prime of x. And then dy with respect to u is going to equal n times u to the n minus 1. Okay, so let's take a look at that formula here. So we have dy over dx, which is equal to dy over du times du over dx. Okay, so let's take a look here. We know that dy over du is equal to the following. Well, that's equal to n times u to the n minus 1. And then we're multiplying that by the derivative of u with respect to x, which is g prime of x. Okay, and so then let's substitute u. We called u g of x, so this is going to be n times g of x to the power of n minus 1 times g prime of x. So what does this tell us? Well, this tells us and gives us the power rule combined with the chain rule. So if n is any real number and u is equal to g of x is differentiable, then d over dx of u to the n power is equal to n times u to the n minus 1 times du over dx, which means that we would get the following result. The derivative with respect to x of a function raised to the power of n is equal to n times g of x to the n minus 1 times g prime of x.